Hi, my name is Katie, and I am the driver for the session, and I'm here with.
Hi, my name is Loveless, and I am the navigator for this session.
Okay, so today we are diving into chapter 15, which is about using swings. The main focus of this chapter introduces Java swings for building GUIs, which is also called GUIs, emphasizing the challenges and solutions for controlling component placements using layout managers. It provides a foundation for GUI programming, including Android apps and development. So, moving on, we have the swing components. So, if you take a look over here, let me just highlight it. So, the component or the widgets are the GUI elements like button, text fields, and list of all extending Java Swing Tray component. Containers, for example, the tray frame or the tray panel, holds other components. Most components can act as containers, allowing nesting, for example, panels inside panels, interactive versus background buttons, text fields that are interactive, frames and panels are typically background containers. However, panels can also handle events like clicks. So I'll just show you a quick example about that. So here we have the code. Here we're just creating the JFrame window. Here we create the components, which is a button and a checkbox. Here we create the panel to group the components of the button and the checkbox together. Here we add the panel to the frame, and here we just trigger it to make it visible. So I'm just going to run that. It appeared. As you can see, here's the button, here's the checkbox. Moving on. So now we're moving on to the layout managers. So first we're going to go with the definition. Layout managers are objects that control the size and the position of the components within the container, for example, the panel or the frame. Hierarchy: each container has its own layout manager, which only controls components directly added to it, not nested components. For example, a frame layout manager positions a panel, while the panel's layout manager positions buttons within. Um, I will show an example now. So here we're creating the main frame. Here we want to center it to the window. Just go with it now. Um, Here we're creating panel A and we're giving it a title border. Here we're creating panel B and giving it a title border as well. Here we just set the layout for panel B to stack buttons vertically. Here we add the buttons to panel B. Here we add the panel B to panel A. Here we add panel A to the frame, and that is where we trigger it to make it visible. So as you can see, button 1, button 2, button 3 are in panel B, and panel B is inside panel A. Moving on, sorry, how the layout manager works. which is how does the layout manager decide? So the layout manager follows specific policies to arrange the components. The query component for their preferred size, but may override these based on their rules. Here is an example process. A panel with buttons is created. The panel's layout manager asks each button its preferred size. The layout manager applies its policies to decide the final size and position, and the panel is added to the frame, and the frame's layout manager repeats the process for the panel. Now we're moving on to the big three layout managers, border flow and box. So the border layer. This divides the container into 5 regions: north, south, east, west, center. Only one component per region, so it ignores the preferred size of the component and it's the default for the JFrame. Next, we have the flow layout, so it arranges the components left to right, wrapping to the next line if needed, like a word processor. It respects the component's preferred sizes and it's a default to the J panel. Lastly, we have the box layout. So it stacks the components vertically or horizontally. It respects the preferred sizes but allows manual line breaks. Useful for vertical stacking without wrapping. Now I think we've reached the end. So basically, why does all of this matter? So the swings challenge. While swing code is simple, layout managers can make component placements unpredictable if it's not understood. Control. Learning layout managers policies allows developers to control the GUI layouts precisely, and in the relevance, mastering swing provides a foundation for GUI programming, including Android apps. Now that we've covered that, I will dive into the final code. So here we have the beatbox, which is the final code. Let me just put this down. Okay, so if you take a look over here, we have our imports. So I'm just gonna do it like this. So here we're importing the Java sound. So this is the MIDI music functionality. Sorry. Okay. Next, we importing the swing. So the swing is for creating the GUI components like the button and the checkboxes. Here we importing the AWT for the layout and the window design. Here we're just importing the array list. This is for using an array list to hold checkboxes. And lastly, we are importing the Java sound short message. So this is just for the MIDI messages constants. And if you take a look over here, this is where we will be where we will list to store all the checkboxes for beat, the MIDI sequencer to play the music. This just holds the musical sequence and this just takes the sequence. So here we have the name of the instruments that will appear on the interface. Next we have the MIDI key for each instrument. So as you can see over there. Now we have the main method, the entry point of the program. So new beatbox Perl GUI. This creates the beatbox object and it calls the Perl GUI to set up the interface. Over here, this just builds and displays a graphical user interface for the beatbox. So over here we're creating the window titled Cyber Beatbox, and then over here we close the program window when the window is closed. Um, Here we're using the border layout to organize the components. This line creates the main panel for the border layout, and then over here this just is the 10 pixel padding around the panel. Here we have the box button. This just creates a vertical box to hold the control buttons. Next, here we create the configures and the start button. So over here we have the button. So when it's clicked, it builds and plays the MIDI track. Um, Here we create and configure the stop button. So when we click the stop button, it stops the MIDI playback. Here we create and configure the tempo button. So here, when we click this button, it increases the playback speed by 3% when clicked. Here we create and configure the tempo button, tempo down button. So when the button is clicked, it decreases the playback speed by 3%. Here we create a vertical box to hold the instrument's name label. Here we add label for each instrument name to the name box. And then here we create a label with the instrument name. Over here we add small padding around the label, and lastly, this just adds a label to the vertical box. Next, this is where we are placing the button box, so the start, stop, etc. on the right side of the main panel. This is where we will place the instrument's name label to the left side of the main panel, and thus air background is the main panel to the center of the frame. Over here, we create a 16 by 16 grid layout for the checkboxes, so 16 instruments and 16 beats. Over here, this is where we set the 1 pixel vertical gap between the checkboxes, and this is where we set the 2 pixel horizontal gap between the checkboxes. Next, we create a panel to hold the checkbox grid. Over here, we add the checkbox grid panel to the center of the main background panel. Here we're just initializing the list to store all 256 checkboxes. Sorry. Yeah, basically we create and add the 256 checkboxes to the grid and list them. So over here, this is where we create a new checkbox. This is where we set it to the unchecked default. This is where we add it to the list by tracking, and this adds it to the grid panel. Yeah, we set up the MIDI system for the sound playback. Over here, we set the window's initial position and size. And yeah, we resize the window to fit all the components, and this is where we trigger it to make the window visible. Thus is where we will be initializing the MIDI system for playing sounds. So obviously this is our error handling. So this will just get the MIDI sequencer. This opens the sequencer for use. Here we create the sequencer with 4 tickets per beat. This creates a track in the sequence, and then this sets the default tempo to 120 beats per minute. And then if it all fails, we will get an exception and it will print the error details for the MIDI setup. Here we are building the MIDI track for the selected checkboxes and starts playing it. So here we clear the existing track to start afresh. Here the track Here we create a new track. Here we loop through each of the 16 instruments. The rate to store the beat pattern for one instrument, and then this just gets the MIDI key for the current instrument. So here we are looping through the 16 beats for the current instrument. So over here it gets a checkbox for this beat. And if it's checked, it marks the instrument to play the beat, and if it's unchecked, no sound will play. Next, we add the instrument speed to the pattern of the MIDI track. Sorry. Here we add a control to change event to ensure the sequencer is responsive. Here we add a program to change the events for the MIDI compatibility. Here we have another error handler. So this just loads the sequencer into the sequencer. Sorry, the sequence into the sequencer. And then this just sets the track to loop infinitely. This just sets the tempo to 120 ppm, and this just starts playing the track, and then this will just print the error if everything fails. Just give me a second. Okay, so now this is where we will be adjusting the playback speed by multiplying the current tempo by a factor. So here we just get the current tempo factor, and then over here we just adjust the tempo, like for example, as we can look over here. Here we add the MIDI note to the events to track the instrument's beat patterns. Here we loop to 16 beats for the instrument. Here we get the MIDI key for the beat. Um, if the beat is active, it adds a note on the event at the current tick, and it adds a note of event one tick later to stop the sound. Finally, here we create a MIDI event specified command channel data and timing. So here we also have a try and catch. This just creates a MIDI message. This just sets the message details, for example, the note on the channel, the note, the velocity. Yeah, we just wrap the message in the event at the specified tick. Next, this will just print out the details event error occurs, and this will just return the MIDI event. So now I'm going to run it, and we should see what the beatbox will look like. Over here, this is the app. So I'm just going to make the sound now. If I do it like this, let's hear what we can come up with. I'm just clicking random boxes. And the stop button works, so I'm going to start and we're going to tempo up. And now I'm going to tempo down. I'm sure we can hear the difference. Let's turn it up again. And that is it for chapter 15. Thank you for watching.